In this video, we will explain the assigned topic 13, which is volume for a solid of revolution. We will explain the theory and the origin of the formula used, followed by the explanation of the given problem. The following theory is about how to get the volume for a solid of revolution. First of all, a solid of revolution is a rotated function y equals f of x on an interval a, b. In order for us to get the volume with the integral, we must rotate the function over the x-axis and get the following dimensions. What we want to obtain is the volume of the inside of this figure, so we use the intervals a, b, then plug the function f of x in the formula of volume, which will be explained briefly, simplify and integrate. Finally, plug in the x of the interval to the value of a and b, then subtract the values, and that will be the volume of the figure.
To find the volume, we're going to use the disk method. This is a formula used to finding the volume of an integral. V equals integral of pi times f of x to the power of 2, or squared, dx. We can also write the equation by just taking out the pi to the outside of the integral sign. This works by the following way. Each cross-section is a circle with a radius f of x, so its area is given by the formula for the area of a circle, which is area equals pi radius squared. So now we plug f of x into the radius, ending up with area equals pi f of x squared. Finally, the dx, in the end, represents the thickness of the disk. Now for integration, use the intercepts you want to compare in order to integrate from number a to number b.
We are going to work with the equation y equals 0.5x plus 1 at finding the volume from -2 to 2. The first thing we need to do is to make a table of values. On x, we're going to put numbers from -2 to 2 and replacing them on the original equation. With that, we get our values to make our graph and find the real shaded area we are looking for in a graph. After plugging -x with 0, -1 with 0.5, 0 with 1, 1 with 1.5, and 2 with 2, we get a straight line. After that, we know that we want to look at the shaded area beneath that line.
So the first step will be to convert our equation to the volume formula. As we can see, our equation is y equal 0.5x plus 1. And the volume formula equals the integral from point B to A, pi times the equation squared. So since our equation has two variables like a and b, we need to multiply them and do a binomial squared. First, we need to expand the binomial squared form, which will be 0.25x squared plus 0.5x plus 1 all times pi of the integral from point -2 to 2. And then we continue with the steps. We multiply the pi to every number, which will end up 0.25 pi x squared plus 0.5 pi x plus pi. And then we finally integrate, which is we need to add a number to the exponent and then divide the whole thing by it. So the first part will be 0.25 pi x to the third divided by 3, and then plus 0.5 pi x squared divided by 2, and finally will be pi x. And then, in order to find the volume inside this specific distance, we need to substitute values. We need to first substitute the x by 2 and then by -2, and then we subtract b from a and we get the final answer. When we plug in our values in the x's, first we get 4 pi, and in b we get -2 pi. When we subtract a from b, we get positive 6 pi.